Hi, so here we are back for part 2. I realized I made a mistake right here. So tangent is supposed to be opposite over adjacent, and this denominator is supposed to be 24. Did I mess that up? So we were looking at angle S. So cosine is adjacent, which is 7, over your hypotenuse, which is 25. And then tangent is opposite, which is your 24, over the adjacent, which is 7. So it says, do you notice anything about the sine of angle Q and the cosine of angle S? They are equal. What about the cosine of angle Q and the sine of angle S? They are equal. Because, remember, the hypotenuse doesn't change, but when you look at the other reference angle, your opposite and your adjacent sides flip-flop. Okay? So there's all kinds of special relationships that are going on when you're dealing with right triangles. Okay, so like I mentioned, all these values for sine, cosine, and tangent are all programmed into your graphing calculator. But again, every day you grab a calculator, you need to put it in degrees. You need to press mode and change it to degrees. And like I said, once it is in degrees, it'll stay in degrees unless somebody changed it back or the calculator has been reset. Okay, so find the value of each expression, round your answer to the nearest 10 thousandths, which is 4 decimal places. So trigonometry, we usually go out 4 decimal places. So this wants sine of 70 degrees. So it is this decimal, 0.9396926, blah, blah, blah. 4 decimal places. We're making a decision about that. 6, that 9 tells us to round up. So we're going to go 0.9397. Number 2, what about the cosine of 20 degrees? So if I press cosine and 20, look at that. It's the same number. So rounded to 4 decimal places. Do you notice anything? They are equal. All right, what about cosine of 40? So now I'm just going to press the cosine button, and I'm going to type in 40. And I'm going to round this to 4 decimal places, so I'm making a decision about the 0. The 4 tells me to leave it alone. So 0.7660. Now let's do number 4, sine of 50. So now I'm pressing the sine button, type in 50. Look at that! 0.7660. Do you notice anything? Those are equal. All right, one last one. What about just tangent of 52? Now, tangents are decimals that are usually bigger than 1. So 1.279. I'm going to make a decision about this 9. So I'm looking at the 4. 4 tells me to leave that 9 alone. Now, how come these have the same value? How come these have the same value? Look at 70, look at 20. Look at 40, look at 50. Anything going on there? Remember, in a right triangle, angle A and angle B are always complementary. They add up to 90. So the sine of one angle is always going to equal the cosine of the other acute angle. Here's why. If you do sine of angle A, here's my opposite, here's my hypotenuse. But if you do then the cosine of angle B, cosine is adjacent, that's this side BC, over the hypotenuse AB. Remember, your opposite and adjacent switch depending on which angle you're looking at. So this is asked all the time. When does sine equal cosine? It's when the angles add up to 90. They have to be complementary. So these examples are always on the region. So it says solve the following. The sine of 42 equals the cosine of, well, you need to remember that these angles have to add up to 90. So we're going to take 90 and subtract 42, and you get 48. These angles have to add up to 90. Here's another one. When does the cosine of 12 degrees, it'll equal the sine of, you have to subtract 78 degrees. These numbers have to add up to 90. All right, so they can get a little bit more algebraic. When does the sine of x minus 5 equal the cosine of 35? When these angles add up to 90. So you're going to take one angle, add the other angle, that has to add up to 90. So now you have a little equation to solve. I'm going to combine like terms. Oops, I don't want an equal sign there. So this is x plus 30 will equal 90. Subtract 30 from both sides of your equal sign. It's when x is 60. When is sine going to equal cosine? Again, it's when these angles are complementary, when they add up to equal 90 degrees. Combine your like terms. Negative 17 minus 4 is negative 21. All right, so now solve, add 21 to both sides. And last step, divide by 3. Go into the calculator when x is 37. Okay? Very, 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 very important. In fact, I'm going to highlight the whole big box here. Okay. Last type of thing you're going to be asked to do is a problem like this. If tangent of theta is 6 over 4, find the value of sine of theta and cosine of theta. Well, I know sine, cosine, and tangent are only defined on right triangles. And here's where I'm choosing to put my theta. You could also put it up there. Doesn't matter. I know tangent is opposite over adjacent. So in my picture, I want to label my three sides. Here's opposite, here's a hypotenuse, here's adjacent. So they're giving me measurements. Remember, these are the lengths of two sides of a right triangle. So my opposite length is 6, and my adjacent length is 4. They want us to now list what's the sine of theta and what's the cosine of theta. Well, for sine, I know it's opposite over hypotenuse. I have the opposite, I don't have the hypotenuse. So if I have two sides of a right triangle, do you remember what we need to do to find the hypotenuse? We need to do the Pythagorean theorem. So 4 squared plus 6 squared is going to equal my hypotenuse squared. 4 squared is 16, 6 squared is 36. Add them together, you get 52. Last step is to take the square root. Now that's okay. We're just going to leave it as a square root. That's totally fine. So now sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. Okay? So here's another one of the same thing. If sine of theta is 2 over 8, now again I know sine, cosine, and tangent only work on right triangles. I always choose to put theta down in the bottom left corner. Now I'm going to highlight. Theta is my reference angle. The side that's not highlighted is always the opposite. The one across from the right angle is the hypotenuse, and the other side is adjacent. Sine is defined to be opposite over hypotenuse. So they gave me the opposite length, which is 2, and the hypotenuse's length, which is 8. Again, I need to find my adjacent. So now that's the hypotenuse. So when I plug my numbers into the Pythagorean theorem, I need to put the 8 on the other side. So I'm going to go and square these numbers. I'm going to subtract. X squared is 60. X then is the square root of 60. That's my adjacent side. Now it wants me to find the cosine, which is adjacent over the hypotenuse. And the tangent is defined to be opposite over adjacent. And we're done. Woohoo! All right, so that is it. Have a great day. Bye.